Moving on to the next question. The next question is also similar type of question. So it says that what are the counting states Q1 and Q2 for the counter shown in the figure below? We have to tell the sequence. Previously, they have just asked us the value for 1, Q1 or something else. So now they are asking for asking states for both the outputs, Q1 and Q2, both the values. Let's just see what's actually visible, the values for J1, K1 and J2 and K2. So we can see from the circuit, J1 value is equals to K1 value, and they are connected to, they both are connected to what? Q2 bar. Q2 bar. Here we can see J2 value is equals to Q1 bar and K2 value is stable as 1 always. Now what we have to do? We have to find out the values for Q1 and Q2. They haven't told us that you have to take the initial value, something like that. If nothing is given default values, you start from 0, 0. Right? Keep the states 0, 0 and then start from that. So if I am taking previous state, J1, K1, J2, K2, and this is your next state. I guess some space problem, but it's okay, we'll manage. Previous is also Q1 and Q2. Next is also Q1 and Q2. These values are same only. And here I will write my clock. Without clock, no sequential circuit. Okay, no clock will start from here. 0. So in 0, 0, I am taking previous states as 0, 0. You know the excitation table for JK. I am drawing it again and again. So JK excitation table. Q, N, not N, Q previous state, right? Q, that is your previous state. This value is 0. So if J value is easy to remember, is J value is 0, its value is 0. If J value is 1, its value is 1. If both are 1, then it is toggling state, right? Now, J is equals to J1 is equals to K1 is equals to Q2 bar. So what is Q2 bar? That will be 1 and 1. J2 is equals to Q1 bar, that will be 1 and K2 is 1 only, right? So what will be the next state will become 0, 0 means toggle. Toggle is, this is Qn bar. So toggle is happening of previous state. Whatever the previous state is, it will toggle, right? So it was 0 before, it will toggle to 1. It was 0 before, it will toggle to 1. So next clock will become, so next state of previous clock will become previous state of next clock. Easy. 1 and 1. Now, J and K values are depending on this only. I have written all the dependence here only. So J1, K1 is Q2 bar. So Q2 is 0, 1. So they will become 0 and 0. Okay. J2 is equals to Q1 bar. So that will also become 0 and K2 is equal to 1 only. Now you see 0, 0 is, that means it will remain in the previous state. So previous state was equals to 1. 0 means 0, 1 means it will reset. Next state 1 and 0, next clock. Now what's happening? J1 and K1 is equals to Q2 bar. So Q2 is this. So 1 and 1. Right? J2 is equals to Q1 bar. So Q1 is 1. So its value will become 0 and 1. Now 1 and 1. 1 and 1 means Q1 will toggle. Right? So it will become 0. 0 and 1 means it will become 0 again. Third. Right? 0, 0. It will start again from 0. So what are the states? What is the correct option? So it's repeating itself after. So if I start from 0, 0, this is not the correct option, right? So We'll leave it from here. They are starting it from 1 1 1 1 1 0 0 0. Yeah, this is your correct option. It is the repetition cycle. So 1 1 1 0 and 0 0, and it will repeat again itself like that. So again 1 1 1 0. So you can see the repetition like this. So option 1 will satisfy itself. 1 1 1 0 and 0 0. So these are very easy type of questions, right? When you have to draw, you have to find the output sequence or whatever. So what you have to see that what are the inputs according somewhere NANDs are connected, they are directly connected to output or input or whatever, right? Somewhere gates are connected, be it AND gate, NAND gate, or any other gate, right? So you have to find out the relations, right, in which the inputs are related, because you have to eventually find out the data. Now tell me, this is synchronous, this is also synchronous, because same clock is given to both. In asynchronous, they are always depending on others' output. Okay, moving on to the next question. Okay, little different question. It is a latch. So two latches are given. One is, this is your NAND latch, and this is your NOR latch. NAND latch and NOR latch. So refer to the NAND and NOR latches shown in the figure. Then the input P1 and P2 for both the latches are made. First it was 0 and 1, then after few seconds it was made 1 and 1. So the corresponding outputs Q1 and Q2. You have to find out the Q1 and Q2 for both the NAND and NOR latch. Before like moving on to the actual circuit given to us, let's just write the truth table for NAND and NOR both. So if I write for NAND, and this is for NOR. So it is 1, 1, 1 and 0. So this is 1, 0, 0 and 0. So these are the truth tables for NAND and NOR. So for NAND, if you see, if there is a presence of any 0, the output will be 1. And for NOR, if you see, if there is any 1 present, the output will be 0. Right, sorted? This thing is sorted. Right, so we have to find out for both the inputs. For first input, it was 0 and 1, and next input it was 1 and 1. So we'll start from the first input. Okay, first input is 0 and 1 in both the cases. Right, you see 0. Just listen and carefully, and you will learn how to solve these latches very quickly, very efficiently. Right, so you see 0 here. You see this is a NAND gate, and if you see any 0, you know the output will be 1. There is no doubt in this, no matter what value of other input is, right? So value of output will be 1. Great. So this 1 is coming here. 1 and 1, we know it will be 0. This 0 will move here, it will become 0. So the value will be 1 and 0. For P1 is equals to 0, P2 is equals to 1, Q1 and Q2 will become 1 and 0. Where should I write them? So for first input 0, 1, NAND is 1, 0, Q1 and Q2 value. Okay, here I'll write NAND, here I'll write NOR values. Okay, now we see this. Now here we are seeing 1. Whenever the either of the one input is 1, the value of output is 0. It's fixed. So 0 will come here. 0, 0 value is 1. 1. So this 1 will come here. 1, 1 value is 0. So its value will become 1, 0. Right? Understood or not? Whenever you see 0 in any NAND latch, value of output will become 1. The other input does not matter at all. Whenever you see 1 in NOR latch, the value of output will become 0. Doesn't matter what the other input is. When you see other input, just move it to input of the second gate. One input you know, other input you just calculated, solve them by checking truth table. So truth table value of 0 0 is 1. Now 1 1 is also 0, so this satisfied and this is stable. Okay, moving on to the next input. So next input is, they are saying that next input is 1. For this also we have to find it out for NAND and NOR both. Let me erase the first one first. Right. So next input is both ones. Now what to do? For NAND, both are 1. So both are 1. It can be 0. And I know only one input. So if other input is 0 and 1, the values of output will change. Right. So in this case, we cannot take it. If both are 1 here in this case, so what should we do? We will assume a value. And we will see if that value is stable in that particular latch or not. Okay, let's just assume Q2 is equals to 0. This 0 will go here. 1 and 0 value will be equal to 1. So Q1 will become 1. This 1 will come here. 1 and 1 value is equals to 0. Yeah, this is stable. So this is stable. So this can be our case. Let's just assume the other value. Suppose this is value is 1. So this value is 1. So 1 will go here and it will become 1 and 1. The output of 1 and 1 will become 0. This 0 will come here. 0 and 1 will become 1. So this is also stable. For NAND latch, if both the inputs are 1, so either of the output Q1 and Q2 is 1 0 and Q1 and Q2 be 0 1. Both are stable conditions. Okay, in both the cases the output will be stable. So it can be either 1 0 or 0 1. So both are stable condition. Now here there is no need to do anything. We see 1 and 1. In NOR case, if any 1 is present, the value of output will be 0. So this will be also 0, this will be also 0. The value will be 0 and 0. Got it? So we just match the answers now. So first is 1 0. So first is cancelled 1 0. Then 1 0. Right, NOR 1 0 and 0. This is also cancelled. NAND 1 0. Okay, 1 0 is also correct. This can be 0 1 also. It's okay. Either of the one option is given. Both are stable cases. NOR first 1 0 and 0 0. So this is correct. So this is your correct option. Okay, so this is the best way to solve the latches, and you will see like latch. If you see the latches, all the inputs you can calculate easily. So in this state, any of the two states is there. So that's why we cannot predict the actual output. Both are stable cases. So it depends on what? It depends on which gate will work faster, right? If this is fast, then this will be the output, and if this is fast, then other will be the output case, right? That completely depends that which of the, and if both are having same propagation delay, then in that case, okay, then in that case, it is unstable. It is giving unstable output, right? Okay, moving on to the next question. Next question. Next question says that for each of the positive edge triggered J, K flip-flop used in the following figure, the propagation delay is delta T. Right, the propagation delay, they have saying that propagation delay by each of them is delta T. Which of the following waveform is correctly representation of Q1? You have to find out the correct, there is no need to find solve for this, that what will be the output waveform. We can easily check it. Now let's just see what type of counter is this. This is synchronous or asynchronous? This is asynchronous. As you can see, clock is given to this and output of one is given to the other one, other clock, right? So this is asynchronous type of counter. This is asynchronous type of counter. Now what's happening in asynchronous type of counter? Now if there are two flip-flop present, because we can see there are two flip-flop present, so it is mod n is value of flip-flop, where that will be the mod value of that particular circuit. So it is mod 2 square, so that will be mod 4. We now know the mod of the, now mod does what? Mod means it will repeat itself after 4 cycles, be it from 0 to 3 clock or from 1 to 4 clock. That is the meaning of mod. That means it will repeat itself after 4 cycles. That means what? Frequency, if the original clock frequency is f0, so frequency will be divided by the mod value, right? That means what? So frequency will be divided by 4, and simultaneously what happened to time period? So time period, if frequency is getting divided, time period is multiplied by that value, right? Multiplied by mod value. So time period will become 4 times, right? So if time period here is t, so time period of output will become 4 times t. Easy, 4 times t. But what about delay? Delay is present because of one flip-flop at a time. If one delay because of this is delta t, delay because of this will be delta t, and output will be having 2 delays, delta t plus delta t. So delay will become 2 delta t. If there is a third flip-flop, then it would have been 3 delta t, and so on. So delays add individually according to flip-flop. So what will be the total delay? So total delay is this, total output time is this. Now you check the frequency waveform. So this time period is 2t? No. This time period is 4t and delay added is 2 delta t, right? This is not. This is also not, because delay added is just delta t. So B will become your correct option. Okay, this is the best way to understand this, because if we find this output, we will get the similar waveform, because what's happening is just take a flip-flop, we have to assume the values and we have to draw the waveform. But what's the need for drawing the actual waveform if we can solve them in such easy manner? Asynchronous flip-flop, you see, just calculate the mod, you find out the time period by multiplying the mod value, right? Or if you want to find out the frequency divided by the mod value. Delay is additive, right? Delay will add according to flip-flops. Great. Moving on to the next question. Next question is also similar kind of question. They are asking you to find out the sequence. We can easily solve it. Let's just do it. So what kind of gate is given? You know the value of D0 is equals to Q0, and this is a NOR gate. Q0 plus Q1 NOR, right? And value of D1 is equals to Q0. This is what's happening, and the value will shift like this. Let's just draw the table in order to find out the sequence. Previous values, clock, previous value, next value. Right, previous value, Q0, Q1, Q0 dash, Q1 dash. For first clock, we will start from initially 0, 0. Okay, what's happening at 0, 0? Okay, NOR table, you know what's happening in NOR truth table. This is your NOR truth table. So now Q0 plus Q1 bar, you can directly do it also. So what's happening for D0? This is also, this means D0 and this means D1 also, same thing. Okay, because they are transparent. So what's happening with D naught value? So D naught value will become 0, 0 and NOR value will become 1. And what's your Q1 value? Q1 value is your D1 value. That means it will shift like this. So it will become 1, 0. Right? Next. First, I have written it like Q0 and Q1, but the options are in this way. So it's okay. We will change it like that. So if I write here Q1 and Q0, so it will become 1, 0. We can alter it later. But now let's just try solving like that only. So next state will become 1, 0. Right? So 1, 0 means the value of D0 will become 0 because 1, 0 is 0. So 0 and this 1 will shift. Okay. In second clock, 0, 1 will come here. Right? And 0, 1 will become 0, 1 is 0 only. 0, 1 is again 0 and this 0 will shift. Now it's repeating itself. In third clock, 0, 0 is coming. So after 3 clock cycles, it's repeating itself. So values will be 1, 0. The values of, so it will be 0, 1 according to Q1 and Q0 in the way the question is asking. So it will be 0, 1 or 1, 0 and 0, 0. So it's repeating like this. So we can start from 0, 0. So 0, 0, 0, 1 and 1, 0. So B option will satisfy 0, 0, 1, 0, 1 and 1, 0 and 0, 0 and so on. Right? So this is your correct option. Okay, moving on to the next question. Because we have done a similar kind of question multiple times, they are very easy now for us. Okay, next question is similar latch type of question. NAND gate latch question is given. They have given you the following binary values were applied to X and Y input and of the NAND latch shown in the figure, and the sequence is indicated below. So the input sequence is given and we have to find out the corresponding stable values of P and Q output. What are the input values given? So first input values are given as 0 and 1. Next values, let me draw it again here. The next values are 0, 0 and finally third values will be 1 and 1. My drawing is not that good. I'm sorry for that. It's okay. We'll understand that how latch is working. Okay, so now we have to find out the corresponding values. Again, I'm drawing the NAND truth table. I'm drawing them again and again so that you just remember them. Like there is no need to draw them separately in your examination. You just remember that. Right? Well, anyways, maximum inputs are covered in this case. Okay, X, Y, and output B, Z. So this is NAND. Right? So this is how NAND works. You see 0. 0 means it will be, output will be 1. So you know that this will be 1. So this 1 will come here, 1, 1 will become equal to 0. So first case, very easily sorted. Now again, next case is also very easily sorted. You see 0, the value of P will become 1. You see 0 here again, the value of P will become 1. Easy. Next case is the similar kind of case. P and this is Q. P and Q. You see 1 and 1. Now you cannot directly write any of the output. Now you have to assume. So you assume that it was, let me take blue color. Okay, you assume that it is 0 previously. Right? If it is 0, 0 will come here. 1 and 0 will become what? 1 and 0 will become 1 and 0 will become 1. So P value will become 1. So this 1 will go here and 1 will become 0. So yeah, a stable case. If I take the another case, so if I am taking this value should be 1. So this 1 will go here, 1 and 1 will become 0 and this 0 will come here, 1 and 0 will become 1. So this is also stable. So in this case, when inputs are 1 and 1, so either of the output can be 1 0 or 0 1. So this can be output. Here output is 1 and 1 and here output is 1 and 0 fixed. So you can match the option 1 0 1 0 1 0 all 1 no 1 1 1 1 1 1. This is the correct option, right? P is equals to 1, Q is equals to 0, P is equals to 1, Q is equals to 1, P is equals to 1, Q is equals to 0 and they have written OR here and P is equals to 0 and Q is equals to 1, right? Very easy latch question which we have already done. Very similar kind of question but little different. Okay, because in this connections are not given, the sequence is given and they are asking you to find out the connections. Previous cases they were giving us the connected circuit and they were asking us the outputs. Now there are two D flip-flop as shown on the figure are connected as a synchronous counter that goes through the following sequence. So in some sequence is given. So this is your present state, this is your next state, in next clock cycle this is your present state, this will become next state and so on. So inputs D0 and D1 respectively in terms of Q0 and Q1 will be. Okay, let's just draw the table. Clock, previous state, we need little more space, next state and the inputs. Right, so previous state Q1 Q0, Q1 Q0 bar and D1 D0, because Q1 is your MSB starting 0. So previous state is 0 0 and it will become 0 1. The values will be also 0 1. Next 0 1 it will become 1 1. Values of input will be also 1 1. Second clock 1 1 output. Next sequence is after 1 1 it's 1 0. The value of input is also, because it's D flip-flop, value of input will also become 1 0. Very easy flip-flop. Third clock from 1 0 it's becoming 0 0 from where it actually started. Right, now they are asking us to find out the value of D0 and D1 in terms of this Q1 and Q0. So you see this 0 1 1 0. So Q0 is also 0 1 1 0. So D1 we can directly write, it's nothing but Q0. D0. D0 is 1 1 0 0. If you see Q1, Q1 is 0 0 1 1. So D0 will become Q1 bar. So how they are connected? D1 is connected to Q1 bar and D0 is connected to, D0 is connected to, right? D1 is connected to Q0 only. So this is how it is connected and D0 is connected to Q1 bar. So this is how the connection is implemented. Right, option, correct option we can see in which sequence they are asking D0 and D1. So Q1 bar and Q0. Option A will be your correct option. Right, this is like a little opposite, but it's okay. This is also very easy. Right, all the states are given. Right, present state, next state and input are reflected directly. Whatever the values of these are similar values of D1 and D0 are. From 0, 0 it started 0, 0. After this it was 1, 1, 0, 1. After 0, 1 it was 1, 1. After 1, 1 it was 1, 0. And after 1, 0 it was 1, 0, 0 again. Okay, great. Moving on to the next question. Next question is a little different question. So for a ring oscillator shown in the figure, the propagation delay of each inverter is 100 picoseconds, right? What is the fundamental frequency of the oscillator output? The oscillator output of this kind of ring oscillator type, so we have to find out the number of NOT gates. So n value is equals to 5. Its frequency is fixed. So its frequency is 2 into n into whatever the delay, t delay, right? So that will be your frequency. So that will be 1 by 2 into, we have 5 NOT gates, 2 into 5 into, and delay of each is 100 watts pico. 10 raised to power minus 12 is pico. So if you solve this, 10,000, so 1 by 10 raised to power minus 9, so it will become 1 gigahertz. So 1 gigahertz will be your correct option. So this is a fixed value. If they ask you for find out the total time period will become just opposite of the frequency. It will be 2 into n into time period of each. That will become your time period. Okay. Moving on to the next question. Finally, a different gate. T, toggle. So toggling means what's happened in T excitation table, the value of T and the value of output. So if T value is 0, the output is 1. If T value is 1, the output is 0. So whatever the value of input is, it toggles, it changes. Right. So this is synchronous type of counter or asynchronous type of counter. Of course, we can see this is a asynchronous type of counter because clock is given here. After that, clocks are given from the output of previous one. Right. Right. So question, let's just read the question. The given figure shows a ripple counter using positive edge trigger flip-flop. If the present state of the counter is Q2, Q1, Q0 is equals to 0, 0, 1, then the next state will be, so present state is given, they are just asking the next state. So present values Q2, Q1, Q0 is equals to 0, 1, 1. So what's happening in this? In this, input to all the T's are given as 1. So that means they are in toggling state already. So what's happening? If clock appears, what will happen? Q0 will become 0 because input of T is equals to 1, and this will become 1. This will become 1. That means it will trigger the next one also. Right, this is already triggered now because this is triggering it. This is triggered now. If clock is triggered again, so that means this 1 will come here. It will become 0, and this will also become what? This will also become 1, and this will trigger the next one, and again 1 will become 0, and this will trigger the next flip-flop. So what's happening? So whatever the present state is, next state will be toggled, will be just opposite. So this is your present state, next state Q2, Q1, Q0 will become 1, 0, 0. So 0 will become 1, 1 will become 0, 1 will become 0. So this is how it will work. So what's the output is B, 1 0 0. Anyways, you can see this is a toggling flip-flop. So next state will be just opposite to the previous one. If it is in toggling mode, because T value is 1, that means it will toggle. Okay, moving on to the next question. Next question. The present output Qn of a edge-triggered JK flip-flop is logic 0. If J is equals to 1, then Qn plus 1. Next state they are asking. So let's just excitation table of JK. Again, I'm drawing it. JK 0 0 Qn 0 1 0 1 0 1 1 1 Qn bar. Next state. Right, so this is what excitation table of JK flip-flop look like. So now they are saying that the present state, so present state means present state Qn is equals to 0. And if I made J value is equals to 1, so either of these cases, if J value is 1, then next state will be equal to what? Right? So now J value is 1 in these both cases, but K value is changing. Here it is 0, here it is 1. So let's just see. If K value is 0, case 1. If K value is 0, the output is 1. That's quite visible. In case 2, if K value is 1, if K value is 1 means it will toggle the previous state. So previous state is this 0. It will toggle it. It will toggle because it is Qn bar. So it will become, it was 0 previously, it will become 1. So does not matter whatever the K value is, the output will remain as 1 when J value is 1. So it will be logic 1. Clear? Moving on to the next question. In next question is little different, where they are saying that a modulo 6 ripple counter shown in the figure, the output of 2 input gate is used to clear the JK flip-flop. Right? They are asking you to find out that gate. First thing first, what type of mod is given? Mod 6. Mod 6. That means it will count up to. This is a 3-bit. So in 3-bit, 6 representation is like this. 1 1 0. That's is clear according to the question. Now they are saying that what is this gate? Right. This gate is the output of this gate is connected to the clear signal. Right. Clear is active low. Active low. Active low means the output should be equal to 0. Right? The output should be equal to 0. What are the input? Now input to this gate, and these values are 110 is C, B, A. So this value should be 110 because C is your MSB. So input to this gate is C bar, B bar, that's it. A does not care at all. So now what's the value of C bar and B bar should be in order to make this value 0? Because C and B value are 1 and 1, so C bar, B bar value should be 0 and 0. In order to make the output of that given gate equal to 0, we need output here to be 0 because it is active low. We need output here to be 0, and we know the value of C is equals to 1, the value of B is equals to 1. That should be equal to 1 because it is a mod 6. the last value it should count is up to 110. So C bar is coming to it, so C bar should be 0 and B bar is coming here, so it should be 0. So what gate provides? When the input are 0, the output should be 0. So gate OR. So gate OR will provide that kind of condition, and also provided, but and becomes 0 for other cases also. OR specifically becomes 0 for 0 case, and become 0 for 0 all these three cases, and will become 0, but we don't want such case. We just want it should become 0 when both the inputs are 0. No other cases we don't want it, right? So it is dedicatedly OR gate. So this 2 input gate is nothing but OR gate. Clear? So this is little different. In this circuit was given, they were asking gate. Previously they were asking us to find out the mod or the values of output, right? In this mod is given, so you have to go do backtracking. Mod is given, so it will count up to 6, right? The output of this is given to clear signal. Clear is active low. Active low means it should output should be 0. So output should be 0. Input are connected to this and this, right? CB value should be 1 and 1 in order to make them clear. So C bar, B bar value should be 0 and 0, of course. C value is 1, so C bar should be 0. B is value is 1, so B bar should be 0, right? They will make the input 0 and 0 and 0 and 0 and output, and now we know both the input and output. Now we have to just decide what kind of gate will provide such type of output. So 0 and 0 and the value of output is 0 is given by OR gate. Moving on to the next question. Next question. The master slave flip-flop has a characteristic that. So master slave is a flip-flop which we have just seen the circuit also in previous questions. So in master slave flip-flop, what happened? There is a master flip-flop, there is a slave flip-flop, and they are connected together with a NOT gate in between them, right? So in this situation, when the slave value is changed, then only the whole value of master slave flip-flop is changed, right? If master is changed, that doesn't matter. Slaves should change. So option number, change in output immediately reflected to the output, no. Change in the output occurs when the state of master is affected, no. Change of the in the output occurs when the state of slave is affected, right? Both the master slave affected at the same time, no. Whenever the condition, whenever the state of slave is affected, then only the output will be changed. Otherwise, the output will remain in the same condition. And this master slave is formed to avoid the race around condition, which we have already discussed. So, race around condition will occur in JK flip flop. This master slave flip flop is also formed by using JK flip flop only. Right? We form it by using D flip flop also, but JK flip flop it's their original flip flop, right? Okay, so that was all for a sequential circuit. I hope you liked the class. So that was all for digital electronics. All the questions we have covered for I think we have covered like around 100 question in digital electronics, which involve all the previous year gate question, and the previous year gate question are considered to be like very good quality questions, because gate examination are set up by IITs, and IIT institution, everyone knows that they are a very premium institution in India. So I hope you like the quality and content of these classes. Like enjoy learning.